Okay, so chapter 6, I am looking at just really question 21. I changed the question in the back of the book, or in the book, because I wanted you just to look at that data set and see whether or not it was normal or not. And you should have noticed right away when you graphed the data that it was skewed right, which means that it's not going to be normal. But I did want you to go ahead and just go through the process of double checking everything and seeing whether or not the normal probability plot was not linear, and if you looked at the percentages, 1, 2, and 3 standard deviations away from the mean, they weren't close to those of the empirical rule. Did anyone go through the whole process, or did you stop at the histogram? You should go through the whole thing. The histogram is definitely some evidence to suggest that it's not normal, but when I ask the question, is the data normal, I am looking for the full, complete answer. So 1, show me the histogram. 2, show me the normal probability plot. And 3, show me the percentages 1, 2, and 3 standard deviations away from the mean. Okay? So I really was looking for that for question 21. Are there any questions about 21 before? Because that one should have been almost identical to the M&M problem that we did in class, right? Just exactly the same, except for just different numbers. Okay, so let me read the answers to the even problems here, looking at question number 8 first. So just check your answers here. And please keep your book out along with you so you can kind of refer back to the question in terms of the context, so you know kind of what we're talking about here. Now, in question number 8, that question was about MP3 players, which is kind of like a little outdated these days since we all have smartphones that can hold music, but that's okay. So we have a mean, we're given a mean and we're given a standard deviation, and so we know if we're going to be able to draw that in question number 8, where do we put the mean? In the middle, right? And so the mean number of hours that it played was 11. And that's for Dura time. This, by the way, should have looked very familiar to the question on your normal probability packet that you had to turn in, where you had to compare pineapple and mango. You know what I'm talking about from that question? So this was very similar. You're just comparing 2 different data sets. So Dura time, and then what was the other name? Rock Ready, and it was at 12. Okay. Now, one of the things that we want to really emphasize is that when we are comparing 2 different normally distributed data sets, we really have to do what with both of those things. In order to compare them to see whether or not one did better than the other, we always should do what with them? Standardize it. So we really should think about z-scores. I'm assuming that's the direction this is going in. I don't know, but I have 2 different data sets with 2 different means, 2 different normal sets, so I'm thinking that should be where your brain goes, okay? That's where you should be thinking about normalizing. All right, so it says here, A, explain why you would also like to know the standard deviations of the battery lifespans before deciding which brand to buy. That's really hard to even say. Why would that be important? Has to go with what I just said.
Because we need to know what the variability is.
Okay, but why do I need to know that?
Because if it has a large standard deviation, that means it could range all over the place.
Okay, that's true, but what does it have to do with what I said earlier? Okay, still what does it have to do with? If I'm comparing distributions, and I want to know whether Dura time or Rock and Ready is better, you guys just told me, what do I need to do? Okay, I'm comparing not the standard deviations, but I'm comparing the z-scores, okay? Because if one z-score is better than the other, then what does that tell me? That's the one I want to buy, right? So if we look at the z-score formula, this is what we need, right? We need the mean, which we're given, and then we need the standard deviation. Once we can do that, then we can figure out what's the better one to buy, okay? All right, part B says, suppose those standard deviations are 2 hours for Duratoons. So let's go ahead and just do 2, 1, 2, and 3. So what would that be? 13, 15, and 17. We'll go in the other direction, and we'll subtract 2. Any questions on what I'm doing there? Okay. Now we're looking at Rock and Ready, and I believe it gave me 1.5 hours. So 1.5 would be, I'll write sideways here, what, 13.5, 15, and 16.5? And we'll subtract and we'll go the other direction. And so I'll have, what, 10.5, 9, and 7.5? We good so far? Okay, good. Then it says, you are headed for 8 hours at the beach. I was just at the beach, I have to tell you, it's kind of fantastic. What battery is most likely to last all day? So I want 8. Okay, well, 2 things. I can kind of highlight where 8 is approximately on the graph, okay? And that tells us something. Or I could also find what the z-score corresponds to 8 for each of them. That's clear evidence to say which one you should buy, okay? So if we do that here, let's find the z-score for each that corresponds to the 8. So when we start with Dura-time, we're going to have 8 minus the mean divided by the standard deviation. And what do I get for that one? They're both negative, by the way. Do you agree? Okay. What's negative 3 divided by 2? Negative 1.5. We agreed so far? Okay. Now we're going to find the z-score. Okay, I'm just making sure that we're looking at the right thing. So just like these are both going to be negative. That's no big deal. All right, so over here we have 8 minus 12 divided by 1.5. Excuse me. What's negative 4 divided by 1.5? Anyone get that real quick? Negative 2.67. Okay, thank you. So we have to, and they're both negative because they're both 8 hours is well below the mean in both of those cases. So that kind of makes sense that our z-score is negative. But when I'm comparing these z-scores, I want to find the one that's going to most likely last that long. Which one appears as though it's going to be a better case for what we want? Dura-time. I agree. Or Dura-tunes, I think it's what it is, right? The first one. When you're comparing z-scores, you want the one that's higher than the other one. Comparing negative 1.5 and negative 2.67, negative 1.5 is better. So this looks to me like the one that we want. Okay? Any questions about that? Let's look at the last one. C, it says if your beach trip is all weekend, and you probably will have the music on for 16 hours, which one would you buy? So what would change in our problem? The z-scores, obviously. And what number in the z-score would I change? The 8 would change to a 16. Okay? So the new z-score that we have would be 16 minus 11 over 2 and 16 minus 12 over 1.5. I don't have the numbers in front of me. Let's see what it... Help me out. They're doing it a little differently in the book. So 16 minus 11 divided by 2. Not 32. 2.5. All right, so 2.5 standard deviations above the mean. That's really what a z-score is, the number of standard deviations above the mean or below the mean. Okay, and then we have 16 minus 12 divided by 1.5, and I have 2.667. Okay, so which one are we more likely to buy if we're looking at 16 hours? They're pretty close. Would you agree? But definitely one is higher than the other. So it would change depending on the number of hours we're looking at. It's more likely to last for that long because the z-score is higher. No? Okay, I see what you're saying. Okay. I know, can we draw a picture? Exactly. Pictures help me. Okay. So if we were to, here's, when we had two pictures, I think is the problem. If I standardize them, and I have 2.5, and I have 2.6 repeating, right? Those both are standardized, and one is the Duratunes, right? So we have Duratunes, and the other is Rockin' Ready, or whatever they're called, okay? If you think about the likelihood, remember that a percentile, maybe that'll help you think about it from that perspective, is from that point on. Which one has the higher percentile that's associated with it? The 2.6, which is what I want. It's no, you're more likely. It has a higher percent. This has a much higher percentage than this. Not much, but it has a higher. No, when I say percentile, it's like if you're in the 95th percentile, isn't that better than being in the 92nd percentile? Think about your scores in terms of like your grades, right? You want to be in a higher percentile. Same thing in this case as well. You want a higher percent chance of likelihood that it will last that long. Yeah. So you want the percentage to be higher. So a higher z-score corresponds to a higher percent because it's further to the right on the graph. If I say it that way, is that better? Still no? Okay, I think the issue is that we've so often been talking about how far from the mean we're talking about. Now I don't want, it's okay to be far away from the mean. Now I'm looking at it as a comparison of the percentage from that point to the low. And it doesn't mean less than in what you're thinking of. It means that's the likelihood that it will last that long. But that's a different question. The question says, how likely is it based on, another way to ask the same question would be, how likely is it that the Duratunes MP3 player will last, what do we say, 16 hours? How likely is it that the Rockin' Ready will last 16 hours? Okay? And so we could find the percentages that are, let's just do that for giggles to show you what I'm talking about. Let me just show you real quick. So if we did the normal CDF, we would go negative E99 to 2.5. Since they're standardized, we don't have to worry about it's 0 and 1. And we have a 99.4% chance. Okay? Now, it's like talking between good and great, right? I mean, these are both going to be great. And then, I'm not done. Let me finish, please. Okay? So we have 6, 7. And then that's 99.6. Okay, so again, both really good. That's the likelihood they'll last that long. Yes? Is that what you're saying?
That would be the likelihood they wouldn't last that long.
You're right. You're right. Hang on. Now you're questioning me. No, you're right. You're right. Hang on. Hang on. No, that's why you're asking the question. So hang on. These are good questions to ask. Let me wrap my brain around it. Oh, hi. Okay, thanks. I want to read it, but I don't. My nosy self, I tell you. All right, so let's stand back, and let me make sure that you guys are asking really good questions. So it's a good conversation to have. So it is 99.4. You're right. It's the likelihood. At least. At most that long. At most that long. Yes. That is, yes, if you say it that way, it's at most that long. Right? Yes, I agree. So what question do you have now?
Would we want to be finding at least that long? Because we don't want a battery that lasts less than 50. We want it to last 50.
Okay. You want to know what the book says? Neither has a good chance. Because that's right.
That's actually what I said.
Right. No. So let me go back to this. So many times, this is where, okay, yes. When you are comparing two distributions, you compare z-scores and you look for the highest z-score. I would say in 95% of the time that's the case. In this particular case, because they're asking you a different type of question, the wording's a little weird, and I agree with both Amanda and Zachary and Charles. You guys are all right. Okay, and Hunter, sorry, I didn't mean to throw you out there. You're in there too, okay? But you're all right. This is the percentage of the likelihood that it will last at most that long, which means the likelihood that it will is not real good. And I agree with you. But neither of them have a very good chance of lasting that long. So, and because we're comparing in this case, the percentages are so darn close to each other. The book just says neither of them. They both are terrible. Okay, that doesn't help me, right? Hey, Devin. Just put your pass on my desk for me, please. It would have a smaller likelihood of lasting that long. I mean, better chance? Smaller chance of lasting. A slight advantage. I won't ask it this way. Okay. And that is okay, Zachary. You did the compliment, and that's perfectly okay. But even, guys, excuse me.
I did the same thing with B as well.
That's fine. You did the compliment, and that's okay as long as you show me your work and you explain what you did. I'm fine with that. So he just did the compliments to find the at least. That's perfectly, yes, that's perfectly okay. But I don't think either of these have a very good chance.
Yeah,
So that's.
There was only a 0.12 difference.
Point. Should be, well, maybe because we rounded, but it should be like close to 0.2%. All right. The answer is not. The answer is just which one is likely. Neither of them are likely. That's the answer. It kind of was. Okay, that's shame on Bach, Velleman, and DeVoe. Okay. Okay, so this actually brings us to one of the main points I wanted to get to today. So if you didn't understand that conversation, at least now perk up. Okay? If a question asks you anything with the following words, okay? Is something likely to happen? Is this an unusual thing? So a different way to ask their question if they're asking about these MP3 players, would it be unusual for an MP3 player to last for 16 hours? That's the way I would ask it on a test or a quiz. Okay? Understand that difference? Okay? Would it be unusual? Well, here's the problem with that, with what I just asked. If you're asked for that, you're going to look at the z-scores. And for it to be unusual, it needs to be more than 3 standard deviations away from the mean. Okay? Are either of these in that case? No. So would it be unusual for either of them to last? No. So to me, did you just call me Ms. Nine again? Okay. Sorry, it's the third time today. I know, it's okay. But so the word unusual, which will come up, and oh, by the way, that was the answer to your extra credit on the binomial chapter 17 quiz. I'm going to hand those back to you today. Because if you didn't take it by now, you're taking a totally different version than everybody else. It talked about, is it unusual? Okay? And so that's what we're looking for. If it says these words, and this is important because you will see this again. So if you don't remember it, write it down. Unusual, likely. You want to ask, is your z-score greater than 3 or less than negative 3? Did I write that down wrong? I did. Okay. Is it less than negative 3 or is it greater than 3? Outside of 3 and negative 3. Hunter. Let me just check. Let me check. Durotune batteries are more likely to fail. What did we say?
So rock ready would be more likely to.
This would be more likely to fail. Yes, it was the wording of the question. I agree. And so Zachary, you did it backwards. You did it using the complement as well on part B. Perfectly okay. Charles.
If it's likely it's inside the standard deviation, it's unlikely it's outside.
That right. Let me say that again. So if we have negative 3, negative 2, 1, 0, 1, 2, 3, anything that the z-score is in between here, it's likely. Okay? Anything outside would be unusual. Okay, so we'll put these in a different color. Unusual. Strange. Weird. It's not likely to happen. Because kind of does, doesn't it? Because I told you the way that the book is asking the question, Zachary, and the way I would ask the question are two different things, okay? The way I would ask this question is the following. Are you listening? I'm going to say it one more time. Would you consider it unusual for your MP3 player to last for 16 hours? No, because the z-score is within 3 standard deviations of the mean, okay? And that's exactly how you would answer that question. Okay? Period. I know. That's okay. I don't mind. We got to move on. All right. What other? This actually was the point of today, believe it or not. So we got there, however convoluted it was. Okay. Question 30 is the one I graded. Do you mind if I just jump to 30 because that's the one that so many of us missed? So let's just jump to that one, okay? So on question 30, it says, and there's parts A, B, C, it says what percent of a standard normal model is found in each region. So I'm going to do, and D is the one I graded, and D is the weird one, and that's okay, because it has to do with this absolute value. I probably will never do an absolute value one other than here. Because you know that the absolute value is positive or negative, so you do the positive and the negative version. All right, so here's the problems, okay? We're going to draw a picture that corresponds to each. If it's a z-score, we're going to put 0 on each one. Not all of us did that. As a matter of fact, very few of us did that. It said to draw the picture. In the problem, it said to draw the picture. Not many of you did. Do you see that where it says that, actually, in the directions? It says, draw a picture first. Not many of you did. So we're going to put the z-score on our picture, negative 2.05. And it says greater than that, so that's where I'm going to shade. So I'm going to shade from here, and that's my picture. Okay? We're going to draw a picture for each of these. Between 1.2 and 1.8 is to the right of 0, and I'm going to shade in between those. I skipped to C, sorry, I didn't mean to do that. Less than negative 0.33. Negative 0.33 is to the left on a standard normal curve, the left of 0. Less than, we're shading here. Any questions about the picture? We're going to go to get the answer in a minute. In the middle, when we have the absolute value of z is less than 1.28, that simply means we have positive 1.28 and we have negative 1.28. Now, how did I get that? Well, we have to kind of remember what absolute value inequalities. I don't know what you remember from Algebra 2 and what you don't remember from Algebra 2. But when you have absolute value of inequalities, you have to write 2 of them. Do you remember this? The first one is simply what you see. The other one is when you flip the direction and you make it negative. Do you remember that?
Yes.
It's from Algebra 2. It is from last year. Okay? And so when you have an absolute value inequality, you have to write 2 of them. It is an and situation because the absolute value is looking at it. So we're looking at this one and the other. Times 2, because there's 2 of them. So if you did that, Zachary, that would be fine. You could absolutely do this. No, I'm sorry. No, that's not true, actually. I apologize. No. It's actually this. It's greater than the negative and less than the positive. Greater than negative, less than positive. I don't know who your Algebra 2 teacher was, Nathan, but she's fantastic. Sorry. Deja got it. It's good. All right, so I'm still not done. All I did was draw a picture, right? So I drew a picture, and so now I have to actually write what we typed into our calculator. Erica, I better see your eyeballs, darling. Erica Cruz, you need to put your head up. Go get some water, take your jacket off, something. We're not safe into class. Go get some water. So if I want to type this in here to my calculator, we have normal CDF. We're going to do our lower bound. We're going to do our upper bound. And a mean, and since they're all z-scores, right? All a mean of 0, all a standard deviation of 1. And the answer that the book got here was 0.9798. Okay? I'm just going to give you the answers to the others, okay? Now that we have a picture drawn for all of them. For B, they got 0.371. For C, they got 0.0791. And for D, they got 0.7995. Okay? If the question said what percent, that would be fine.
Okay.
If it did. It did. For what?
I did it for Robbie 1, I run it to 0.07.
Perfectly fine. Okay, any questions on that one? Do you see how drawing a picture can really help there? It's really important that you do that, okay? Really important. I get why we might have forgotten about it. I understand. Okay? You probably won't see absolute value. I know you won't. But it's important to look at. Yes.
Just making sure. So
Okay.
For B, you would put the
Normal CDF, and it would be
the lower would be like
yeah, like negative
upper,
E99. Upper would be no. Upper would be negative 0.33. 0, 1. That's the answer.
I meant like.
Yeah, I understand.
0.
Okay, good. Any other questions? You sure? Okay, how to do 35. All right. It's taking a long time to go over homework today. That's okay, though. All right, 35 is a good question. So let's look at that one. So here is some notation that that AP loves to use. So we need to really understand what this notation is even saying, okay? And I probably should have introduced the notation before I gave you the homework assignment, but if you did read the chapter, it was in there. This is a notation that can be used for any of these. Let's pretend like we know what all of the models mean. What would N versus B versus G mean? N would stand for normal, okay? B would stand for binomial, and G would stand for, okay. When we have the B, the binomial, usually you are given this information. What would N stand for? Number of trials, P is the probability of success, and X is what you're looking for. Often they don't give you the X because when we're just describing the model, this is what you're given. Okay? With geometric, you're given the same information. Okay? N and P. I would. It's a notation. What do you think you're going to be given with N? What two things do you always need to know? Mean and standard deviation. In that order, actually. Okay? So you're going to be given the mean and the standard deviation for that particular model. Okay? So notationally, that's what's happening here. That is something you absolutely should 100% know. I can see on a future test or quiz me giving you the information written like this, as opposed to saying the mean is, the standard deviation is. Just giving you that notation. It's pretty standard across the board notation in statistics. All right, so let's go back to the problem. So we're given this information here, okay? We have a normal model. We have a mean of 1,152 and a standard deviation of 84. It says, what are the cutoff values for? Okay? Now we're talking about weights and normal cattle and 33 and whatever. I don't really care too much about that, quite honestly. I'm not worried about the context here. The highest 10%. All right, so I'm just going to put, if you don't mind, my mean. It's drawing a picture. Well, I don't put my standard deviation on. We want the highest 10%. Okay, making sure. Yeah, highest 10% of the weights. Okay, so what I'm going to be looking at is if I shade here, what percentage would be here? 10%. Would you agree with that? Any questions about that picture? Okay, we're okay? When I give you, first of all, if I'm ever given the percentage and I want to find an answer, because don't we want the number that's associated with this right here? Isn't that what we're looking for? Right? So if I'm kind of working backwards, right? I've given the percentage this time, so what am I looking for? What function am I going to use on the calculator? Inverse norm, right? But I'm not going to use 10%.
0.9.
Right.
Because of the other.
That's right. Of course, it's something different, right? Because remember that when you do the inverse norm and you're given a percentage, it's always a less than situation, okay? So when we type this in, we're actually going to use inverse norm of 0.9. It's the complement, okay? And then because I don't want to have to deal with z-scores, I'm going to go ahead and plug in the mean and the standard deviation right here. So I'm going to plug in 1,152 and 84. So a picture and what I typed into my calculator must have both with the correct answer for full credit. And they got here 1,259.7 pounds. Is that what you get?
Yeah.
Okay, good. 59. Let's try it for the other one. So part B says the lowest 20%. Okay, so again, if I'm drawing my picture, I keep forgetting the mean, 1,000. I need new glasses so bad. And we want the lowest, what percentage was it? 20, thank you. So the lowest 20, I don't have to use a complement here, do I? Because it's a less than already. So we're just going to do inverse norm, 0.2, and then plug in our mean and our standard deviation. Is 84? Why did I think 87? Because I can't remember anything. And in this case, they got 1,081.3 pounds. How'd we do? Okay. And then I think part C is just asking for the middle 40%, a little harder. We want the middle 40%. So we have to be very careful. We need to, it's kind of like when you have to subtract some things for the binomial. Okay? If it's the middle 40%, we need these two values it's associated with. So how do I plug that into my calculator? Well, what is each tail going to have in it? 0.3, okay? So wouldn't this value here just be inverse norm 0.3, right? Because it's from that point to the left. And then the mean, whatever your mean and your standard deviation are. Wouldn't this value be inverse norm 0.7? Very good. And then your mean and your standard deviation. No, 0.7. 0.4 plus 0.3. Right? Could add them together. And you're just finding the two. I think that's all it's asking you to do, right? Yeah. And so the two values were 1,108. Would be this guy here. And it was 0.0 actually. And this one over here was 1,196.0. Okay. Are we okay with where the 0.3 came from? Daniel, I don't see eyeballs. I'm making sure. You okay with where the point 3 came from? Daniel. No? Okay, look up here then. Look at me. Turn your body. Don't get like me. Okay. If point 4 is in the middle, and we know that everything underneath the curve has to add to be 1, what's 1 minus point 4? 0.6. And since there's 2 tails, 0.6 divided by 2 is 0.3. Because they have to both add up to be 0.6. Because it's symmetric if it's the middle percent. Is that better? I'm looking. Some people are quiet in this room. They don't speak up. Do we understand? Okay. You have a question? You're getting ready. I thought you were getting ready to raise your hand. Okay. That's all I want to talk about in terms of normal curves. Okay? Are there any questions you have for me outside of the homework? Anything else? I am going to grade the packet that you turned in, and it will go on this quarter. Okay, just FYI. So, but I have a feeling that is the last graded assignment that goes in between. So what do you have? You have an investigative task, that graded assignment, and then if you didn't take your Chapter 17 quiz, that goes in too. Because there are a couple of you that didn't take that yet. It was, yeah, way back in the very beginning of the quarter. Yeah, one of them, I forget. We still have something else to go in.
Are you graded or like it has just
That's a long time ago. So, what we need to talk about is what's coming up in the next couple of class periods. Okay? We are, for the most part, we have one small little portion left on probability, and it's called Combining Random Variables. I believe it is Chapter 16, which I think Kyle and Jasmine have already done. Let me make sure that that's what it is. Yeah, it's number 6, Chapter 16. And we will do that after the midterm, okay? So we typically, well, actually, you should not have many midterms this year because they're canceled across the board for the most part. But I've been given permission because we are an AP class. It does have an AP exam at the end of the year, and we didn't have a first quarter test like you did in a lot of your other classes. I have to give you some kind of summative assessment, okay? Just because I can't wait until the very end of the year and, wow, do you remember what happened back from quarter 1? You know what I'm saying? So we're going to, that's what's coming up. And I gave you a review packet for it before winter break. So those were one set of problems. If I remember correctly, I had you skip a couple of them. At this point, you should be able to go back and look, especially at the normal curve, the problem. I did give them back to you, I think. Oh, I have them. I'll give them back to you then. Remind me I'll do that today. Okay? Then I do have them. So if you would, everyone should have picked up a review packet for the review for the midterm. They're right up here. Anybody else not get one? I put them up here. No one paid attention to me. What else is new? All right. There you go. All right. There you go. Sure. Okay. So this is more than one exam practice put together. Okay. I believe already, I'll have to double check, put an answer key online. If not, I will do that this afternoon. But if you look at the very front, it just talks about the topics. Okay? Do I think you need to do this whole thing? No. Okay? Is it going to be required to turn in for a grade? No. Okay? But maybe extra credit on the midterm. I think I will do it for that. I will do that. Okay? So it will be extra credit on the midterm. Good call, Deja. Okay? Excellent. If you do it.
if we do all of it, the whole thing?
I don't know.
A lot.
If I only do questions 1 and 2, will you give me 10 points of extra credit? I don't know. No. Yeah. Just do it and you'll get 100. No. I don't know. No. No. All right. You're all being on recorded. You know that, right? All right. Here we go. We're moving on. All right. So there is something that you do need to make sure I have. It's chapter 16, yes. Under Unit 4, where it says probability, random variables, we did not get to chapter 16. Do you see that? On the very, where it says midterm topics, cross off chapter 16. We didn't get to it. I have to look. There probably are a couple of places where it might show up. I will find those numbers and tell you to omit them. I'll probably have to do that on the actual exam as well. But if you look, we've covered quite a bit this year already. When we get back from when we start second semester, we'll finish up combining random variables. It's going to spend a day or two on it. We'll take a test. I hate to test y'all to death on normal, binomial, geometric, and then combining random variables. And that'll be our last probability test. Okay? And then we're moving on into our last major unit. And I divide it up into little units, but it's called inference. And we spend the rest of the year on it. Yeah. It's a really important big unit. It is not hard. What it is like we're going to do what are called hypothesis tests, and there are like 8 of them. And each of that, but once you get the pattern down for one, it's the same for all of them, okay? I promise you. It is. It's, what 5 steps do we do? It's like over and over and over again. It's just that each of the tests, like knowing when to use which test can be hard. We'll worry about that at the end. And they each have what are called a separate set of conditions that you have to check. And that's just memorization. So it's really not hard at all. It's just a matter of, I think, honestly, probability is by far the hardest unit that we do in this class. Okay, in my opinion. Historically, the grades have been lowest on that unit than any other, which is why this year I broke it into 2. Normally, I give you one test that covers everything from the beginning of probability all the way to the end of combining random variables. I thought that was mean. So I actually divided it up. I thought that was better, but we'll see how that goes. Anyway, so you have a practice exam. I'm going to give you the multiple choice portion of it on Thursday. So here's what I would like for you to do. Go ahead and the first part of this, by the way, is multiple choice. All the way to 40, okay? And there will be 40 multiple choice questions on your test as well. Now, 40 is a magical number because there are about 40 multiple choice questions on your actual AP exam as well. And guess what? You have about an hour and a half to take it. So the midterm will mirror the time that's necessary on the AP exam as what you'll do on your semester exam. Okay? It's about 2 minutes a question, right? And honestly, some questions go really fast. Okay? Wow. So yeah, you have 90 minutes to do 40. 45, I think.
Is there an advantage
Shh. Yes, we're going to talk all about that. Absolutely. Now, in years past, and you will see, this is an old review, at the very top you will see where it says how I'm going to grade it and all of that. I'm not doing that. I'm not going to grade it like an AP exam would be graded. Okay? I'm going to actually just, it's right or wrong. Now, Amanda asked on the actual AP exam, and once it gets closer, we are going to be delving into a lot of this and what you want to do. You want to eliminate 2 questions as best as possible. 2 answer choices, sorry. Eliminate 2, and then you can guess. Leaving them blank is fine. They don't count against you. Getting them wrong does count against you. All of that stuff is there. It's the same as COPO. It's the same as your SAT. Okay? Oh, you haven't done either of those. All right.
What?
Like if you got the question wrong on the COPO exam, it goes off.
I believe that's all the same. Yeah, it counts against you. It doesn't count a full point. It counts like 0.25 off. It's just like the SAT. They're written by the same company. Anyway, but honestly, it's if there are only so many choices, guessing in theory shouldn't hurt you. What? Right, you know?
Or in certain cases, it's
5, but you know with AP, there, or with stats, it's A through E or F or higher score. But there's going to be questions that, can we just move on? All right, I don't want to waste time. I mean, we'll definitely when it gets closer, we'll talk more about that. But on the midterm, it's right or wrong, okay?
There's 50 questions. It would be better not to answer anything, get 26 wrong.
Yeah, you not to answer anything. You're not going to get points if you don't get points for answering nothing.
I know.
You don't get
any take
okay, but you're not starting with 100. You're starting with a 0.
Oh, wait.
So you don't want a negative score.
I was thinking that.
The way that you can't, but I'm just trying to make a point here. Like you have to answer. You get points for answering correct. So you get points for what you know, not what you don't know. It's how they're trying to scale it. Okay, based on that, is there anything just looking back at old topics that you're like, crap, I just don't remember that, like at all? Anything that jumps out glaringly at you? Look over your topics on the first page first. Gathering data. Kyle's taking that test this afternoon.
It really was. I actually did work in that.
But notice what it says in parentheses, vocabulary. Do you remember it? Got to remember it. So that's what we need to study. So you know that's a weakness for you, right? So that's something you would want to be looking at, okay? Don't just gloss over the stuff we did at the very beginning of the year. Like, do you remember in a box and whisker plot that the quartiles represent 25%? Do you remember what an ogive is? What's an ogive? I think we should probably talk about that. Guys, there's way too many conversations, honey. Brenda, go ahead. It is a cumulative frequency plot. So here is an example of what one might possibly, potentially look like. Okay, and this is a cumulative frequency. Sometimes they are written as percents. Sometimes it's written as just a number. So out of 900, let's say that let's say there were 900 students polled. Okay, so I'm going to go from 0 to 900. Okay, so we have, 1, 2, 3, 6, 900. Okay, and so that would be an example of an ogive. Let me make it go all the way up. All right, okay, whatever. All right, so if I asked you, for example, what was the first quartile, what would you do? %. The problem is I don't have percent here. If I did, I would just go up to 25%. Remember how we did this? We go up to 20 and we go over and down. That would be your number. That's what we're talking about. But I don't have percentages, so what would I have to do first? Find 25% of 900, which is what you just did, right? So 25% of 900 looks like a 225. So we would go here at 225. Wherever that is. We'd probably use our sheet of paper. Remember how we use the corner edge of our paper? And you go straight down here, and whatever number that would be is what we would be looking for. Just because, do you remember this? It's been a while ago. Okay. All right. So here's what we want to do. Oh, you have a question first, or are you just playing with the snow? Okay. Go ahead and be looking at some of these. Maybe you have some people at your table work at the front. Maybe some of you work at the back. And we can, in 5-10 minutes, can you answer this question? I'll be glad to. Okay? And I'm going to put an answer key online so you can check your answers to the multiple choice. Okay?